The purpose of this video is to walk you through how to make your bar graphs in Microsoft Excel, and once you have your bar graphs, how do you add your standard error? So the first thing you'll notice on my screen is that I have the raw data for 3 different treatments of the koi fish experiment. The first treatment is the control treatment where all genotypes had the same relative fitness. The second was where the homozygous dominant individuals had a 0.5 relative fitness to the other genotypes. And then the third treatment was the relative fitness I moved to 0.1. So I have recorded all of the data for my genotype frequencies and my allele frequencies for 3 trials of each treatment. Now, the first thing that I need to do in order to make a graph is I have to calculate the averages of the data because I don't want to have 3 separate bars for the same set of data. So you'll notice I have a row for the average, and in Excel, if you type the equal sign and you begin to type the word average, that formula will pop up and then it'll have you select your range of numbers, which would be the 3 trials. So I'm going to hit enter. And I'm going to use that data in order to make a graph for this. Additionally, because we're calculating averages, we also want to calculate the standard error, so we can add error bars to show the variance among our different trials for one treatment. So to calculate the standard error of the mean, I'm going to type the equal sign, and the formula that I need to use is the standard deviation, and you type in STDEV and then those parentheses. You're going to select your 3 sets of trials, just like you did for the average, but we're not done with the formula yet. You actually have to do the square root of the number of trials you had, and in this case it's just 3, so I'm going to type in 3 and hit enter. Now, because I have that formula in each of these cells, I can actually carry this formula all the way across my different genotypes and alleles. So I'm going to highlight both of the average and the standard error rows, and once those boxes are highlighted, you can see I've got a white plus sign, and when I hover over the bottom right hand corner, it turns into a black plus sign. If I click that as I drag it to the right, it will input that formula into the other cells, but it reflects the column that it's in. Now I want this same data for my other treatments. So I could re-enter the formula, or Excel allows you to copy and paste the formula, and as long as I have the same number of rows as I did in this first data table, it'll do the calculation correctly. So I'm going to right click and choose copy, and then I'm going to go to the average for the next one, and I'm going to hit paste, and the formula transfers over, and I'm going to check my formulas. So the average is reflecting B11 through B13, which are these 3 data points. And then if I do the same thing for the standard error of the mean, it does the same formula for B11 through B13. So that worked. And then I'm going to do that same thing for my last data table. Double check the formulas to make sure they're reflecting the right cells, and we're good to go. So I want to take this data and I want to actually put it into another format for graphing. So I'm basically trying to separate my genotype frequencies from my allele frequencies. You can also do this for scaling up for the population size. You'll have the same trend of the graphs, but the values on your y-axis will either reflect the actual frequencies or it will reflect what it is of a population of 300. You need to do the scaling up for doing the chi-square calculation. So for transferring my averages to these data tables, I could sit here and I could type them out where this would be 0.153, but there's also a trick you can do in Excel. If you copy or if you highlight the first set of data of just the averages, and then you hold down your command button if you're using a Mac. If you're using a PC, you'll use your control button, and you do those 3 data points for each of the subsequent treatments. If you copy this data and then you go over to where you've got it set up for making a graph, I'm going to right click here, choose paste special, and I want to paste just the values. If I do the formulas, it will not transfer the correct numbers, and you'll notice that the data has already transferred over. So I'm going to do that same thing for my allele frequencies. So I'm highlighting my averages. I'm going to copy, and then I'm going to paste special and values, and it transferred all those values as well. I have another set of tables that I've created too, that these are the standard errors. So I'm going to highlight the standard error values for my allele or my genotype frequencies. I'm going to copy, come over here, paste special, and then I'm going to do that one more time for my allele frequencies, but the standard error, copy, paste special, values, and now I have everything I need to graph. So to create a graph, I'm only going to do the genotype frequencies as the example for this, but I'm going to highlight from this first empty box down all 3 rows and all 3 columns to the last set of data. I'm going to go to Insert, and I'm going to go to Recommended Charts, and it's not giving me any options popping up. So I'm going to go to just the column charts because we're making a bar graph since all this data is discontinuous and can stand on its own. And I'm going to pick the first option because it's typically the simplest, right? So it pops up, and what I'm checking is that everything is laid out how I want it to be. I am comparing my genotypes, which that's appropriate, and my y-axis values are less than 1 because I'm using the frequencies instead of the population size. And my labels are appropriate for my columns, so my legend is correct. So before I keep going, I want to make some adjustments to this graph so I can actually see it a little bit more clearly. You could put this on a new page if you wanted to. And then I'm going to go to the home option, and I'm going to increase the font size up to about 18 so I can easily see all the values. You can also reposition where your legend is. Since I went back to this home page, I have to go up to the bar at the top and go to Chart Design, and I'm going to actually choose Quick Layout, so that way it will add the ability for me to put a y-axis label and x-axis label. So I'm going to choose this layout 9. All right. And it has moved my legend to the side. I can adjust all of these parameters if I want to. The chart title, I'm actually going to delete that from the top because in scientific graphs, we actually add a figure caption below that includes the figure title. And then we can adjust the y and x-axis labels. The y-axis, since I'm using the genotype frequencies and it's the average, I'm going to put average genotype frequency, and my x-axis are my genotypes. And I'm not done yet. The next thing I need to do is add the error bars. So if I click on the bars, you'll see that it becomes highlighted, and I'm going to go up to this option that's Add Chart Element, and I'm going to go down to where it says Error Bars, and I'm going to choose More Bar Options, and I want the values to go above and below my averages. I do want caps, so it shows me where my errors actually end. You do not want a fixed value though. What you want to do is do custom and specify the value. And in this particular instance, I have to kind of re-navigate my screen so I can see everything. That is where the error values come from. If I highlight all 9 data points and I do that for the positive value, and I copy that and paste it for the negative value, and I hit OK, it's not letting me do the range. So it wants me to do each bar separate. So since the blue is the relative fitness of all of them at 1, I'm going to change this, instead of being all 9 values, to those 3 values. I'm going to copy that and paste that for the above and the below, and I hit OK. And you'll notice that the error bars actually reflect what our standard error is up here. And then you have to do the same thing for your next set of data. So I'm going to add error bars and do more options, the direction both, the cap, and then custom, and I want to specify my values, and it's going to be these 3 values because it corresponds with the homozygous dominant, heterozygote, and the homozygous recessive, and I want that above and below, and that should reflect those data points. And then I'm going to do the same thing for the 3rd bar, and you just do chart element, add error bars, more options, keep everything the same but adjust the custom, and then this time I'm going to specify the corresponding data points, copy that and paste it for the negative and hit OK. And now my graph is actually ready to almost insert into a Word document. The final thing you should do to make this a scientific graph is you want to actually turn it into a monochromatic graph, and typically I say use the bolder colors. So when you're in the chart design options, there's a change color option. With this change color option, you can do grayscale for all of it, or you can pick a bolder grayscale that does even darker ones so they're more distinguishable. And then you will right click on this figure and you'll do copy. And then when you have your Word document, the Word document, you will actually paste this figure into your Word document. And I always recommend that when you're doing this, that you want to, I'll actually show you. You want to right click and do paste special and paste it as a PDF. The reason I recommend doing this is it retains the formatting. If you do not retain the formatting, it starts to do weird things when it's linked to the original file. Then you just hit enter, and underneath your figure is where your figure caption will go. So I'm going to give a generic one for this just to give you an idea of what you're supposed to do. So you do figure, and since this is my first figure, I'm just going to call it 1, put a period, and then you want to add a brief informative title followed by a period. And then you want a brief procedural description, which should actually include what program you used to get the data and how the data was collected, such as what parameters you used. And then you want a brief description of anything for interpreting the graph, which would include like the error values being the standard error of the mean was how they were calculated. And that is essentially what you need to include in a figure caption. The other thing is our new writing guide actually suggests bolding the figure number and the figure title so they stand out, and that's what I'm looking for these figures. You should have 2 figures, one for your genotype data and then another figure for your allele data.